Alright, so we just learned about the different types of nuclear decay, alpha, beta, and gamma. So now I kind of want to walk you through how to do some of these chemical reactions. If you notice, they're set up in the same way that our chemical equations were set up back when we did chemical equations. The arrow is showing you that a reaction has occurred. Everything on the left side are your reactants. Everything on your right side are your products. And if you guys remember, we have three types of particles. We have our alpha particle, which we write as a fish. It can also be represented as a 4,2-He. We also have beta particles, which we can also represent by using 0, -1, E. And then we have our alpha particles, which are basically just energy, so we do not have a chemical symbol that we can use, and they most likely will not be found on our sheet today. So if you read the directions up here at the top, it says, please fill in the blanks to complete the following nuclear reactions. Please use a periodic table. I do not expect you to have masses and atomic numbers memorized. Also, I would like for you to please write the type of nuclear decay that has occurred to the right of each reaction. So over here, I should at least see alpha, beta somewhere telling me, or if you want to write it out, you can write alpha and beta out. But you do not forget that step. Everybody always likes to forget that step. Alright, so you guys know that I like to walk you through a few of these. So I'm going to do the first 3 on this piece of paper, and then I'm going to pick some out a little bit farther down. So I'm going to do 5 altogether, 5 out of the 18, and then the rest of them are going to be left up to you. So let's look at number 1. Now, if you guys remember back with balancing chemical equations, you have to have conservation of mass. So whatever is on the left side of the arrow has to be on the right side of the arrow. So our reactants have to equal our products. So if you look over here, we have 19 protons and we have 42 mass units. So whatever's on the left side has to be on the right side. So that means we need 19 in total over here. Now we already have a -1. So you have to think to yourself, what minus 1 equals 19? And that's going to be 20. Okay, this is 0, so what plus 0 equals 42? That's an easy one. That should be 42. So then you're going to look up at the periodic table. You're going to try to figure out what the symbol is. Again, to figure out what the symbol is, you look for what the atomic number is, not at the atomic mass. So the atomic number 20 is going to be calcium. So our product that is going to be made through this reaction is going to be a calcium atom. And then now my next step is going to be what type of reaction has occurred. So as soon as you see this, we should be able to identify this equation as a beta reaction. So let's go ahead down and let's look at number 2. If you notice, number 2 has a blank right here because we can use the periodic table to look up the atomic number for Pu. So if you look up there, it is a lanthanide, which means in the last row of the periodic table. It is number 94. So, but we're going to do the same thing. Whatever's on the left side has to be on the right side. So if we have 94 protons on the left, we need 94 protons on the right. So we already have 2. So what plus 2 is going to equal 94? That's going to be 92. Okay, another way to think about it is treat this arrow like a minus sign. So 94 minus 2 gives you 92. 239 minus 4 is going to give you 235. So again, if you look it up in the periodic table, you're going to look up this number, not this number. If you look up there, we get that number 92 is uranium. So now all we have to do is identify the type of decay. This atom right here is telling you that this is a helium, so we are dealing with alpha decay. Okay, let's go ahead and do number 3. Number 3, we are starting with uranium and we are ending with thorium. So instead of the first 2 gave us our beta particles, our beta and alpha particles, and we had to figure out the atom. This time around it's giving us the atom and not the particle. So same process though, addition and subtraction. We have 92 atoms on this side and only 90 over here. How many need to be in the blank? So 92 minus 90 will give us 2. 235 minus 231 will give us 4. 4, 2 from the periodic table is helium. which is giving us our alpha particle. So this is also going to be alpha decay. So there's the first three, and those are pretty straightforward. So I'm just going to kind of skim through here really quick and see if I can find a little bit more difficult ones. Let's look at Alright, let's look at number 9. Number 9 I like because we have a coefficient right here. So you have to remember that this coefficient gets distributed to everything after that. So we don't have 1 neutron, we have 3 neutrons. So whatever's on the right side must equal what's on the left side. So since we have 1, 2, 3 things on the right side, I'm just going to really quickly add all those numbers together so I know what the total number is. So my protons, I'm going to have 56 plus 36. So on this side I need 92 protons. And then I'm going to do the same thing for the mass units. I'm going to do 142 plus 91 plus 3, because we don't have 1 neutron, we have 3 neutrons, for a total of 236. So our total mass and our total atomic number is listed there. So whatever's there has to be on the right side. So 236 minus 1, so we're going to have 235. And then we have 92 minus 0, it's going to give us 92, which is again going to give us uranium. Now, do you see alpha or beta? No, I don't see an alpha or a beta particle. So in this time, we can just leave the type of nuclear decay blank because I didn't teach you all the different types. I just taught you the 3 main types. Alright, so let's do one more. Let's do 18. You guys always want me to do the last one. So let's go all the way down here and let's look at number 18. Okay, so again, this time I have 3 things on my reactant side and only 1 thing on my product side. So we also have a coefficient here, which means we have 2 heliums and 2 electrons. So I'm going to do the same thing I did in the last step, and I'm going to add them all together so I know what I'm dealing with. I'm going to have 214 plus 2 times 4, which is 8, plus 2 times 0, which is 0. So our total number of mass is going to be 222. When we're talking about our protons, we're going to have 84 plus 2 times 2, which is 4, plus 2 times negative 1, which is negative 2. So altogether we are going to have 86. So whatever's on the left side has to be what's on the right side. Since there's only 1 blank over here, that means all of this has to be over here. So we're going to have 222 masses, 86 protons. Look up in the periodic table, number 86 is radon. Now we need to identify the type of radioactive decay that occurred. We see beta and alpha particles, which means that this reaction is both an alpha decay and a beta decay. So I've done 5 examples for you. Hopefully you guys can get through the rest of them on your own. Again, use your partner for help. I don't mind if you guys help each other, just please don't cheat. If you don't know how to do it on your homework, you're not going to be able to do it on the test, so make sure you know how to do it, make sure you're understanding how to do it. If you guys get out of hand and the cheating gets really bad, I can always tell you guys just to work by yourself silently, which is no fun. So just, if you're going to work with a partner, make sure that you're working and not cheating.